Earth is great, but what if there are planets out there even better for life or more exciting to explore? Imagine worlds with more resources, unique features, and even better habitability than our own pale blue dot. What if we could leave Earth behind and venture to these distant shores, to stand on the precipice of new worlds and gaze up at alien skies? Today we're going to explore 5 such planets, each holding the potential to be, in its own way, better than Earth. Our first stop takes us 1,400 light-years away to a star remarkably similar to our own Sun. Orbiting this star, we find Kepler 452b, often called Earth's older, larger cousin. This planet is about 60% larger than Earth, placing it in the category of a super-Earth, and it orbits within its star's habitable zone, the sweet spot where temperatures are just right for liquid water to exist on the surface. Think about that for a moment. Liquid water, the lifeblood of our planet, could be flowing freely on Kepler 452b. Rivers carving their way through alien landscapes, vast oceans teeming with unknown life, possibilities as endless as the cosmos itself. Kepler 452b is also older than Earth, significantly older. While our planet formed about 4.5 billion years ago, Kepler 452b has existed for around 6 billion years. Imagine the evolutionary processes that could have unfolded over such an immense timescale. Life, if it exists there, has had an extra 1.5 billion years to evolve and diversify, potentially leading to ecosystems far more complex and wondrous than anything we've ever imagined. Now, I know what you're thinking. 1,400 light-years is an incredible distance. Even with our fastest spacecraft, it would take us millions of years to reach Kepler 452b. But here's the thing. Distance, as we understand it, is a human construct. In the grand scheme of the universe, 1,400 light-years is but a stone's throw. The discovery of Kepler 452b and other similar exoplanets has fundamentally shifted our perspective. It tells us that Earth is not unique, that planets like ours, and perhaps even better, are scattered throughout the Milky Way galaxy. And who knows, maybe one day, far in the future, humanity will develop the technology to bridge these vast cosmic distances, to set foot on Kepler 452b and explore its hidden wonders firsthand. Our next destination might surprise you. We're staying a bit closer to home, venturing out to Saturn's largest moon, Titan. Now you might be thinking, a moon? How could a moon be better than Earth? Well, Titan is no ordinary moon. It's a world unto itself, with an atmosphere thicker than Earth's, and a surface sculpted not by water but by liquid methane. Imagine this, vast lakes and seas of methane stretching across Titan's surface, reflecting the dim light of the distant sun. Instead of rain clouds, we have methane clouds, releasing their liquid payload onto the moon below. It's a world both familiar and utterly alien, a place where the very building blocks of life might be different from our own. Titan's thick atmosphere is also a major asset. It protects the surface from harmful radiation, making it a potentially safer environment for future human exploration than, say, the surface of Mars. And while the temperatures are frigid, averaging around -290 degrees Fahrenheit, the presence of organic molecules on Titan suggests that some form of life, perhaps methane-based, could already exist there. Now, I know what you're thinking. Methane lakes and frigid temperatures don't exactly scream paradise. But consider this. Titan offers us a unique opportunity to study the potential for life in an environment vastly different from our own. It's a chance to expand our understanding of the very concept of life, to see if it can arise and thrive in conditions we once thought impossible. And who knows, maybe one day, far in the future, we'll develop the technology to terraform Titan, to warm its surface and create a more Earth-like environment. It might seem like science fiction, but in the vastness of space, anything is possible. Chapter 3. Proxima b, our next-door neighbor. Our cosmic journey now takes us to Proxima Centauri b, or Proxima b for short, a planet that holds the distinction of being the closest known exoplanet to our solar system. Located just 4.2 light-years away, orbiting the red dwarf star of Proxima Centauri, Proxima b is tantalizingly close, at least in cosmic terms. This proximity makes Proxima b a prime target for future interstellar missions. While 4.2 light-years is still a significant distance, it's conceivable that we could send a probe to Proxima b within a human lifetime using advanced propulsion technologies that are currently under development. But here's what makes Proxima b truly fascinating. It lies within its star's habitable zone, meaning that liquid water could exist on its surface. Now, Proxima Centauri is a much cooler and fainter star than our Sun, so Proxima b's habitable zone is much closer in. In fact, the planet whips around its star in just 11 Earth days. This close proximity has its downsides. Proxima b is likely tidally locked to its star, meaning that one side always faces the star, while the other side is perpetually shrouded in darkness. This would create extreme temperature differences between the two hemispheres, potentially making the planet less hospitable to life. However, recent studies suggest that Proxima b could have a thick atmosphere and a global ocean, which could help to distribute heat more evenly around the planet. If true, this would significantly increase the chances of finding life on Proxima b. Chapter 4: Mars, humanity's next home. Our next stop takes us to a familiar destination, a planet that has captivated the human imagination for centuries: Mars. The red planet, our celestial neighbor, has long been considered a prime candidate for future human colonization. And for good reason. Mars is relatively close to Earth, with a journey time of around 6 to 8 months, using current technology. It has a solid surface, unlike the gas giants Jupiter and Saturn, and while its atmosphere is thin, it's enough to provide some protection from radiation. But what makes Mars truly special is the potential for terraforming, the process of transforming a planet's environment to make it more Earth-like. While terraforming Mars would be a monumental undertaking, it's not outside the realm of possibility. Imagine this: vast solar mirrors placed in orbit around Mars, reflecting sunlight onto the polar ice caps, releasing trapped carbon dioxide into the atmosphere. This would thicken the atmosphere, warm the planet, and potentially melt the ice caps, creating liquid water on the surface once again. With a thicker atmosphere and liquid water, Mars could become a second home for humanity. We could grow crops, build cities, and create a new branch of human civilization on a planet once thought to be barren and lifeless. Of course, there are challenges to overcome. The Martian soil is toxic to humans, and the lack of a global magnetic field means that Mars is exposed to harmful radiation from the Sun. But these are challenges that we can overcome with ingenuity and determination. Chapter 5: Gliese 581g, a super-Earth with potential. Our final destination takes us to Gliese 581g, a super-Earth located about 20 light-years away in the constellation Libra. This planet, twice the size of Earth and with a mass about 3 to 4 times greater, orbits a red dwarf star, Gliese 581, which is much smaller and cooler than our Sun. Now, you might be wondering why a planet orbiting a red dwarf star is so intriguing. Red dwarfs are the most common type of star in the Milky Way, and they have incredibly long lifespans, far longer than our Sun. This means that a planet orbiting a red dwarf star would have a stable environment for billions of years, potentially giving life ample time to evolve. Gliese 581g is particularly interesting because it lies within its star's habitable zone, the region where temperatures are just right for liquid water to exist on the surface. However, because Gliese 581 is a much cooler star than our Sun, its habitable zone is much closer in. This means that Gliese 581g is tidally locked to its star, just like Proxima b. One side of the planet always faces the star, while the other side is perpetually shrouded in darkness. This would create extreme temperature differences between the two hemispheres, making the planet less hospitable to life as we know it. However, some scientists believe that Gliese 581g could have a thick atmosphere and a global ocean, which could help to distribute heat more evenly around the planet. If true, this would significantly increase the chances of finding life on Gliese 581g. Outro: endless possibilities. From the methane lakes of Titan to the potentially Earth-like conditions of Kepler 452b, we've explored just a handful of the countless worlds that exist beyond our own. While Earth is our home, the universe is full of possibilities. One day, humanity might call one of these planets home, but that's a story for another time. Next time, we'll dive into the harshest planets no one could survive on.